Wait, will they be able to hear us?
Yes, they will.
Is that a good thing?
Well, I suppose if you're asking a question, yeah.
Alright, grand. No bother.
So Kieran in the resources has a sample test, which is built up of 3 parts, and each part has 3 questions, and you answer 2 for each one, right?
Class.
So,
Wait.
yeah,
Wait, where do we find this? It's on Solus, is it?
it is.
Yes, sir.
If you go into week 4,
Sure.
and yeah, and then if you look up sample, and it's like near the bottom. So, a Class C network has the following IP address with a subnet of the following. If I want to broadcast the information to all hosts in the subnet, which of the following addresses should I use? Would anybody like to give it a go? Or, well, I just do my own attempt.
I know the answer, but I don't know why it's the answer.
I know the answer, but I kind of know why it's the answer.
All right. I think Eamon will be good because he will correct me, because I think my logic is working here, but it's not the proper explanation. So, because we have however many zeros we have in the bit for each subnet, each of them have to be a 1. So this is the equivalent of 8 bits being 0. So when each of them are 1, this will also be 1 in the placeholders. So when all the bits are 1, it's actually 2 of 555. And I know that's the answer, but this is my explanation, and it's so bad. Anybody would like to correct me? That is a big silence.
No, thank you.
I'll have a go at it. So 192.168.5.0, that's your network, like. And then if you look over at our subnet, we've got 3 255s. So those 255s indicate that the address is. Sorry, I have to go actually.
GG.
I have.
What color do we use? Yellow and yellow. Anyways.
His mom told him to get off the game. So sad.
Anyways, do we go to the next question, or?
Yeah, sure, when he comes back.
In the meantime, right.
Thank you.
So we have a screenshot of a Wireshark. The figure below shows whatever. In what set of bytes would you find the IP address involved in the transmission? Right, so I would assume by process of elimination, by looking at the image, you guys will be able to figure it out.
Yeah.
But, just so you know, so the frame contains the file size. The Ethernet contains the MAC address of the source and the destination. The Internet Protocol contains the source IP address and the destination IP address. The transmission just describes where the file is going, and then the rest we just don't really care. Anyways, so the IP address is contained in the transmission protocol. No, sorry, Internet Protocol. Application layer protocol that allows dynamic assignment of IP address to computers in the network is known as.
Is it D? I remember looking that up.
It is.
Yeah.
DHCP.
DHCP. Now, if somebody wants to know what it stands for,
Doesn't matter.
Dynamic Host Configuration Protocol. Heck yeah.
I'll be honest, I cannot remember these long ass terms no matter how hard I try, so I just remember the acronym and what it does.
Yeah.
Did he mention it?
Like no, he did not. We looked it up in the lab, so I don't even know what the other three stand for.
You don't know what the other three stand for, no?
STMP is used in emails and stuff. That's from one of the quizzes.
Oh yeah, that's one quiz. Yeah.
Simple mail transfer. Wait, I might as well look up the other
It's
two.
actually in the assessment quiz.
Can these people not come up with better names for this shit? It's a fucking headache.
Address resolution protocol. The fact that Kira knows this, big respect for that man.
Man's a computer.
Is a walking database.
Lives in the cloud.
Internet control message protocol.
He's a walking
Jesus
ARM
Christ.
processor.
Oh, what? Mail.
Simple mail transfer protocol, that's what it was, no?
So it's something like that.
Yeah.
Yeah, which one?
No. What do they all do? One's email, the other one is for
This one is
allows Dominic of Simon to IP address to the computer network.
my assumption is this one is used for controlling messages. So if you send a
how'd you figure
text,
that out?
well, I just looked up the acronym, Internet Control Message Protocol, and based on control message, I just assume if you're sending a text via SMS or something like that. But if we want to get into more depth, you see, the fact that I don't know this, to me, gives me the sense that like he didn't go through this fully. So instead of him wanting you to know what these are, he just wants you to see if you actually know which one is the one we were learning about.
Yeah.
I mean, networking is meant to be a huge part of his module anyway. It's
Especially
literally just this, but
if you're doing cybersecurity next semester.
yeah.
Given the following IPv4 address and subnet mask, select how many hosts can be allocated to the subnet from the options below. Okay, this one is a nice one. Right, we're going to do the workings. So I usually convert this into binary. So 10 in binary is... Hold up. Okay, so 10 in binary is an 8 and a 2. So, fuck's sake. 2, 4, 8. The 20 is a 16 and a 4. 16. And then 0, 0, 0. Cool.
Wait, isn't it 2 0 0 1 0?
Oh, fuck, I'm an idiot. Sorry.
As
Yeah, we're actually meant to convert this one.
Yeah, so all of them are going to be 8 except for 252, which is just missing 2 ones at the back.
Thank you.
And and 0 as well. 0 zeros.
Right. It's missing 2 in the back. Oh.
Sorry, 3 bits. It's technically 3 in binary, but 2 in bits. 2 1 bits.
Oh, okay.
Yeah.
Right. So basically, this is my subnet mask, right, in binary. And, you know, if you see 255, you just know that there's 8 ones and then another 8 ones. And you just calculate this one. Now, you will count the number of zeros because in order for you to assign in a IP address to your network, it has to be a permutation of ones and zeros after the last one, right? So we have 10 zeros, which means I can have a combination of 2 to the power of 10. So 2 to the power of 10 is
1024.
And 24. But when all of these are 0, if somebody's trying to connect to your network, it's actually returning the IP address. And Kieran also said that when everything is 1, that means you're pinging every device on the network. So these are the 2 IP addresses in the subnet that you are not allowed to use. So you will always have to subtract 2 from however many the combination is. So it will be 1022. Is that an answer? It is. Any questions?
No.
Brenny, that wasn't a very convincing.
That makes sense.
That was class.
Consider the following below. 3 links, each will specify transmission rate and link length.
Wait, actually, wait. Why'd you minus the 2? It's the...
Yeah, that's okay. Right. So we have 10 zeros.
Yeah.
So we could get 10 combinations or 2 to the power of 10 combinations of zeros and ones. Does that make sense?
Yeah.
But that includes when all of them are 0 and also when all of them are 1.
Yeah.
But we're not allowed to assign that to any computer because these are actually commands. This one is to give back this IP address, and this one is to ping every computer on the system. So,
okay.
So you have to remove those two, and then you're left with 1022. Find an end-to-end delay, including the transmission delay and propagation delay on each of the 3 links, but ignore queue delay and processing delay. From when left host begins transmitting the first bit of a packet to the time when the last bit of the packet is received at the server at the right, the speed of the light propagation delay on each link is 3 times 10 to the power of 8 meters per second. Note that the transmission rate are in megabits per second and the link distances are in kilometers. Assume that the packet length of 16,000 bits. Give your answers in milliseconds. Feel like I'm leaving some maths. So I am just going to pull out my notes because I can't remember. All I know
It's L over R when we are discussing
That-
bits and distance divided by speed when it's when we have to find the propagation delay.
So the transmission delay, the formula is like you said.
L divided by R. L is
divided by-
length of the bit. L is
Yeah.
length of the packet. R is the rate of transmission.
Divided by rate of
No, not length. Length. The length of the packet.
yeah.
Yeah.
And then
Rate of transmission.
cool. And that will give you I think some value.
Time.
One sec.
Usually in milliseconds.
Alright, yeah. And then the other one was the other formula for calculating the propagation. Propagation is distance over speed. So that's when it's actually traveling in the cable. Cool.
Yeah.
Distance. Speed. Right.
Feel that, Axel. Feel that. Fuck me.
So we have 16,000 bits. Anybody would like to give me a hint how to approach this question?
Sub in the values.
Okay, that's one way of doing it. So I have for the first one. So for the first link, I have 16,000 bits, which is the length, divided by transmission rate, which is 100 megabits per second. 100 times
10 to the power of 6.
10 to the power of 6, which will give us some value. Fuck.
So
I hate this app. Fuck this. Right.
1.6 into 10 to the power of negative 4, or
6.
1 second. 0.00016, which is the other way around, or just 6 into 1.6 into 10 to the power of negative 4. Sorry.
-4. But is that in milliseconds or seconds?
In milliseconds.
This is already
Well,
milliseconds.
Seconds.
Okay,
So-
so that's seconds. So in order for it to convert that to milliseconds, I think milliseconds is to the power of -6. if I'm not wrong. Okay, never mind. Center power minus 3. So that will be 1.66. Oh, 16.6 milliseconds. So that is the transmission rate for the first one. And then for the transport is, we have 3 kilometers. That is 3,000 meters divided by 3 by 10 to the power of 8, which will give you a really small number.
No, wait, that's 3 times 10 to the power. Oh, no, wait, never mind. Okay, yeah, it's fine. Why did two multiplication symbols? I don't understand.
Because in some programming languages you use asterisk asterisk to represent power. And
Okay.
he's just doing that.
Okay.
Okay, 3E8, I have my calculator out, which is like 0.00001 second, and to convert that to milliseconds is I shifted three decimal places, so 1, 2, 3, 0.01 milliseconds. That's the first one. So for the second one, we still have the 16,000 bits. 16,000. And we're processing 10 megabits per second. So 10 by 10 to the power of 6, which is 6 seconds. And then 500,000 meters divided by the speed of light, which is going to SL. Divided by 3 by 10 to the power of 8, or 3 by 10 to the power of 8, and that gives you 1.66 milliseconds. Sorry, 16.6 milliseconds. And then for the last one, we are processing 1,000 megabits, and we're going to kilometers. So by the way, 1,000. Zero point zero zero. Seconds, and then for the speed is 2,000 divided by the speed of light. Milliseconds. Oops. Now, to add the answer to the question is, so we have calculated the speed of processing at the first station, and then for it to travel through the cable, then being processed at the second router, and then traveling through the cable, and once again processed by the last one, and then traveling through the cable, and then your answer is only adding the 6 values together. And then whatever that value is the answer. Any questions? Because I was doing a lot on the calculator.
I think it's fine.
Yeah.
Looks alright.
I like that.
Cool, yeah. Consider the following screenshot from Biochart. Oops. So we are connecting to a server as you can see. In which protocol layer would you expect to find a 48-bit MAC address? Would anybody like to answer that?
It's the Ethernet, isn't it?
It is Ethernet. And for those that are wondering, the way you tell the difference between the MAC address and the IP address is the IP address has a dot, IPv4 has only a dot, and then the MAC address always has a colon. What is the IP address of the server computer? So the way you tell that, well, actually, Kieran, I think you connected to the. He's clicked on the first one. He has. So you look at where the get is. So that means you are sending it to the server. So this is your IP address, and this is the server you are connecting to. 65.182. And what TCP port is used by the server computer? So what port does the server use?
80.
Thank you.
By the way, 80 is also like in one of the slides you said it's also kind of a default server port as well.
It is a default. It's not like a rule. It's like just a convention. We have been using 80, and if you want to host your own server, you would use 80 as well.
Why is Jacob X server?
Yeah, I was about to say, why is his server muted?
Who is?
Jacob X.
Jacob. Admin abuse.
Oh wait, Sammy's here. That's why.
Wow, he's deafened him as well.
I didn't do that. I just joined.
Why? There's no other admin in this server.
Man,
Yeah, he joined muted. I didn't mute him. He joined muted.
Oh shit! Nick must have bullied him.
Oh,
He's a poor Discord mobile user.
Wait, is Marty still here?
oh, he left.
Oh shit! Oh shit!
I got embarrassed.
Oh, he doesn't know. I don't think he
Oh,
knows.
he can't hear us, yeah.
Yeah, he
Oh
doesn't know.
shit! Oh shit!
He's trying to figure it out.
left.
He's trying to figure it out because he's on his phone. Wait, I'm new.
Wait, hold up.
He's left.
Come back.
Fuck, delete that.
He will help.
Anyways, let's continue. Link layer, network layer, blah blah blah. Cool, yeah. Consider the following diagram.
No.
Is he muted?
No, he's good.
Jacob, what's the crack?
He still can't talk.
Oh, okay.
Here I am.
Oh, never mind. Mute him. I'm joking. Anyways, so I'm sending data from computer D to computer A. So when I'm sending,
Don't mind me, sorry.
at least he's... Someone mute him. Anyways, so what is it? Okay, so if I'm sending the data, what is the destination IP address at 0.5?
0.5.
So I'm sending a packet from D to A, and my packet will contain a destination IP address when it reaches the... Is that a router? Yeah, that's a switch and that's a router. Yeah, so it reaches the router, and the destination IP address is actually going to be...
This one.
Okay, I'm lazy to... Fuck, wrong button.
It won't work. You can't.
It's an image.
Yeah, we're gonna copy and paste the image as an answer. Boom. Right. So that is actually what the packet contains. Now, the source MAC address, so where the packet is coming from.
Wait, hold on. Is it not the IP address of the router? No.
The router has no IP address.
At 0.5. No, that's a switch. No.
No. This is a switch.
No, the switch of the square thing is the router's the round thing.
Router's the round thing.
Oh,
no?
for fuck's sake! Sorry, it's the other way
the
around.
destination IP address is that of the router. No.
No.
Yeah.
Well,
It is.
No. That's the destination MAC address. The computer only knows the IP
No.
address.
I don't think so.
That's what Kieran said in the tutorial. Hold on, I have the sheet with me.
Pints.
Oh, lads. We're gonna get into a fight here now in a minute. Hold up. Right, so... You know the last tutorial?
Yeah.
Yeah.
No.
What is the source at 0.5? And for the source we put in the computer D. Oh, it's the exact same question. So he put in the source MAC address is 10.1D, which is that yoke. The destination MAC address is the destination of EF. The source IP address is 128.199. The destination IP address is this. And I asked him, why is that? Why does he not know it? And basically what he said, this computer knows where he wants to send the file, but it doesn't know which computer has the address, if you get what I mean. So the computer knows the IP address to go to, but all it knows is that this is where the connection stops. So it just knows the MAC address of the router, or whatever this is. Does that make sense?
Yeah.
Yeah.
I just had it the other way around as well.
Destination MAC address at 0.2. So when the packet comes here, the destination MAC address is actually going to be this one. Because now what happens is the packet leaves the router, but now it knows that this thing is connected to the computer along the switch. Oh, and that's a sample test. Any questions you would like to go through?
It's close to Mike.
Can't ban him. Oh fuck, I don't know what Sarai invited him to. Jacob, I didn't mean to. Anyways. Any questions? I'm gonna take that as a no, and I'm gonna assume that you guys are all prepared for tomorrow.
Yeah.
Sorry, what was the question again?
I said, do you have any questions?
Yeah, what was the question again?
Hans, I'm gonna mute you in a minute. I would. Anyways.
Wait, will you
do you know how
put
to
that
tell? Do you know how
into the chat thing?
the solutions that I just did?
Yeah, please.
Yeah, I'll do that. No worries. Do you guys know how to figure out which one is Class A, Class B, and Class D type network?
Yes.
I
You
do
do?
because of Stephen earlier
Fuck yeah.
in the library.
Clash.
Can't do a rename.
Clash.
Is this where I load up CSGO?
Yep.
Reviewed.
Привет, вкусно, вкуски.
I got my food. It just came.
You're Chinese.
Yep.
Nice. Why is the announcements not safe for work?
I don't know. I didn't
Wait,
design
whoa.
it. I didn't design that, okay? It was Sam. Even though I have full power to remove not safe for work.
You literally right click and
Sample. Do I need to? Who knows it's not safe for work? Oh, anyway, sample test.
Oh, also
Solution.
send a time traveler.png and psychedelic hot dog PNG.
Anyways, actually, I don't think this one is bad, and I don't think that's bad either. Wait, why do I have this? Oh shit! Fuck yeah! Okay, basically, I downloaded an AI. It was coded in Python, and you describe an image to it, and then it just
you told
and
me
then
about
do this, yeah. And I think I typed in hot dog, or someone else did, and then just yeah.
Fucking weird.
or the time traveler. According to the AI, this is how a time traveler looks.
Like marshmallow. Wait, how long does it take to create it?
Kriwa. It depends on your GPU.
Oh,
Yeah.
No, yeah,
Oh,
and I
yeah.
think because the fucking remember the deep fake thing I was using, that would take like a couple of minutes. That's a Python bolt.
Jeez, couple minutes.
Right,
That's fucking
yeah.
good. Like the one I was using with my 1060, it would have taken. Okay, depending on how many layers I want, it gives you a more accurate one. So if you wanted to get a good image, you should do 11 layers. But with my GPU, it would have taken like half an hour.
wow.
I mean, my laptop does have a 1660, not the
I
flex.
tried.
Fuck
I
yeah.
actually tried to print a 10 by 10,000 array or something, or 1,000 by 1,000 array, and BlueJ would take a century just to print that out. I think I put a file of that somewhere. It was about 6 megabytes long. It wasn't finished. Yeah, it's in hashtag chat.
We should all delete System 32.
You,
Right after you.
Okay, I'll go first. Bye, guys.
Ah, Ewan. I just saw. You put in how to solve Keen's question. Wait, Ewan is not even here. He fucking left to play CSGO.
Priorities. Man. CSGO
Actually.
only comes and goes.